The next thing we're going to look at is area of a circle. Welcome to part 2. So for a circle, if we're graphing a circle, here's going to be our general formula for that. And this is with a center. The center of the circle is at the coordinates HK. Our R is the radius. Okay, so that's kind of our general starting point. So if we look at this problem, they want us to write the equation of a circle with the given information. So they want a center of 3, -2, tangent to the equation y equals 5. So the center part is kind of a simple part to start with. So it's minus the x value and then minus the y value, which you can add the opposite. They're going to just write that as y plus 2 quantity squared. And then the only question here is, what is our radius? Well, tangent means that the line or the circle, there's a line that's just barely touching the outside of the circle. So if this is the line y equals 5, and here's our center of the circle, then we just need to figure out how far that is, and that's our radius. So if you think about what we did, we just went straight up from the center. So we just changed the y value. So basically we went up from 3, -2 to 3, 5. 3, 5 would be the point where that would intersect that line. So if you're going up from -2 to 5, you could split that up and think about -2 to 0 would be 2 units, 0 to 5 would be 5 units, so that's 7 units altogether. So we have a radius of 7. And if you can just kind of visualize that going from -2 to 5 being 7, that's fine also. So that would be 7 squared, which they're probably going to go ahead and just put that as 49. Okay, so this would be our equation in a little nicer looking format. The next thing mentioned is circumference of a circle. Circumference is the distance around the circle, and that's equal to pi times the diameter, or 2 pi times the radius. Just glancing through the first sample questions, I didn't see anything with that, but be good to know the formula, and then we'll just look at all the other sample questions they gave us and see if we come up with anything else on that. But just knowing the formula, and probably just knowing one or the other would be sufficient for that. The next thing we talked about was quadratics, general and vertex form. So general form for a vertex, or sorry, for a quadratic would be like y equals ax squared plus bx plus c. So for example, y equals 2x squared minus 3x plus 4. Okay, that's a general form. These quadratics are basically, they're going to look like either a U shape or an upside down U. It's called a parabola. Parabola, okay. So that's the general form for these. The vertex form we've got would be y equals a times the quantity x minus h squared plus k. And this is where our vertex is at the point hk. The vertex that's either the highest or lowest point on the graph. Okay, it's the maximum or minimum point. So kind of if you go back and look at these graphs over to the side here, you can see these red dots that I just drew. Each one of those would be the vertex for that graph. So for example, they could say if we have an equation y equals 2x squared plus 5x minus 9, they could say what point would be the lowest part of this graph. So the lowest part of this graph, first of all, we got to think about, well, they kind of give it away, but this is a positive number, means it opens up. Remember, this is like the smile, opening up, positive, smiling person. If it was negative, it would be opening down. So since it opens up, it's going to have a definite low point, which is going to be the vertex. So the vertex, if it's in this form, it's not quite as easy just to see it. We have to do this negative b over 2a. So this is a, this is b, so negative 5 over 2 times 2. So that'd be negative 5/4. Not the greatest numbers. Let me just change that. We'll make things a little nicer here. Let's make that a 4 instead. Okay. I don't think they'd give you anything maybe quite like that with your time constraint. So that tells us x is equal to negative 1. And then we just need to put a negative 1 back in place of x and then work this out. You could actually, with your calculators, you could just type all this in there. Probably would be good to put parentheses around that negative 1 and stuff like that. But anyway, we could work it out by hand, but you could technically just type that in your calculator, which would be negative 3. So that tells us that negative 1, negative 3 would be the vertex for that graph. The next part is transformations. There's different things you can think about with transformations for math. You could think of just translations, like sliding something, reflections, flipping something, rotations, turning something. Looking through the problems, what I saw was they had stuff with matrices. So with matrices, we could have something like this, and then it could say it's going from that to something else. What's going to happen when you have a matrix set up like this? These are going to be like your x coordinates on top. These are your y coordinates on the bottom. So this is like the point negative 2, 4, and 1, 3. So if it's going to something else, let's say it goes to 1, 4, sorry, 1, 4, and 7, 6. Well, let's change that. 1, 4, and 2, 1. Okay, what we're doing for this transformation, we're basically just looking from one of these x's to another x, what happened, and it should be the same for all of them. So if you go from negative 2 to 1, well, if you'd rather, you can pick this. We go from 1 to 4, if that looks nicer. 1 to 4, that'd be adding 3. And then for the y's, we're doing the same thing. So maybe we go from 4 to 2, would be subtracting 2. So if we're adding 3 to our x and we're subtracting 2 from our y, then that translation, plus 3 for the x, that would be to the right 3 units. And then subtracting 2 from the y, subtracting 2, that would be going down 2 units. Okay, and you can just verify that works with those other points as well. The matrices that they give you here could be bigger than this, which would just mean you have more points, but just look from the same spot to the same spot. Top left to top left, bottom left to bottom left. As long as you're consistent on where you're going, starting and going to, then it should be the same for the other ones. If you have time, you can check the others as well. Would be a good idea though. The next thing we look at is matrices, dimensions of matrices. So that's like how many rows and columns we have. So this one, basically, it's rows and then columns. So rows. This has 2 rows, and then it has 3 columns. So this would be called a 2 by 3 matrix. Okay. There's a lot of other questions they can ask us besides that, so I'm not sure if that's going to be like the main thing that we're going to see a question about, but just in case, those are dimensions of a matrix. And I see now this is translations of matrices, so I just did a problem on that a little bit ago here. So we can look for other translations, sample questions, and see if there was any kind of, like I said earlier, translations, rotations, reflections. But translations with matrices, we already looked at that. Sorry about that. The next thing is addition and subtraction with matrices. So it's pretty straightforward with that. We are just taking numbers that are in the same spots and either adding or subtracting those. So let's say if we were doing a subtraction problem, if you're subtracting, then this is kind of like adding the opposite to all of these. Change all those signs, and then we're just combining things that are in the same positions. So 4 plus -1 then would be 3. You could have just looked at it as 4 minus 1. And then the next thing in the top right corner, we've got 2 plus -3, or you could have just looked at it as 2 minus 3 if you didn't change the signs. That would be -1. Bottom left would have been 3 minus 7, or 3 plus -7 is -4. And then 5 plus 2, or it would have been 5 minus -2, but becomes 5 plus 2 would be 7. Okay, so when you subtract, it would look like that. If it's adding, then it's the same idea, except you don't have to do any sign changes. You just start working it out just like it is. Scalar multiplication with matrices is just if you have a number in front of a matrix, then you just multiply that number into each part. So 2 times 1 is 2, 2 times -2 is -4, 2 times 3 is 6, 2 times 6 is 12. The next thing is multiplication of matrices by each other. So just to go with something similar to an example that they have, let's say we had this matrix, and then we had this other matrix. Okay, and then the question they gave is just, they said find the first row of AB. So AB would be multiplying these together. So if we were multiplying these together, what we'd start with is we take the first row of A and then we multiply it by all the different columns of B. So it's kind of like we're taking the 1, 0, if you can imagine taking the 1, 0 and then turning it. If that makes sense. So we got 1, 0, and it's like we turn it and then multiply by these, multiply by these, multiply by these. Is kind of what's happening. Okay, so for that first part, we can visualize this over here. So we're doing 1 times 5 plus 0 times 6. And then we're going to do 1 times -1, just moving it over to the next column, plus 0 times 3. And then we're doing 1 times 2 plus 0 times -4. So that'd be 5 plus 0, -1 plus 0, 2 plus 0. The 0 is kind of nice to have there. So this is 5, -1, 2. And that would be our first row when we would multiply those together. If they asked us for the whole thing, then we would go ahead and do the same thing, only we would be taking the 3, 2, turning that and multiplying to all 3 of those. Okay, so basically we would end up with 2 rows and 3 columns for our final answer, but this would be the first row if we multiplied those together. The next thing is the determinant of a 2 by 2 matrix. So 2 by 2 matrix, say we got something like that. This is pretty straightforward once we know how this goes. We're just multiplying diagonally, so -1 times -2, and then minus the other diagonal. So minus 7 times 3. So this would be 2 minus 21. You can add the opposite if you want. That's going to be -19 would be that determinant.